Yep. Good evening to all. Okay.
Good evening, sir.
So today we're going to start with the project. And first we'll do the second project. Second project will be a bit easier than the other two projects. So first we'll do the second project. Then we can see the first project and the second project, third project. So how we are going to do the project is that on the first day, I will give an overview of the project, and then we can go through on all the problems that are present in that particular project. Okay, orally. You can take the next 2 days, okay, to practice, and then try to solve the problems. And then the same problems we'll try to implement. Okay, so wherever you're finding it difficult, uh, so in those ways, I will help you in completing the project. Okay, the other 2 days, we can solve the problems in the class itself. Before that, you have to try all the problems, at least go through all the problems and then find out the logic. And then whichever is possible, you can solve it and come. Okay, for the next upcoming classes. Okay. So First, we're going to see the clustering algorithm. So which clustering algorithm we have taken is hierarchical clustering algorithm. So before going into that, we should understand what is meant by clustering. So any idea, anyone? What is clustering? Okay. So clustering is nothing but grouping. Okay. So like if we have similar elements, okay, so it is actually a machine learning algorithm. So we are not going much into machine learning concepts and all. So we can directly see what is clustering algorithm. Then we can try to solve this problem. Okay. So what we have done is actually we have taken a problem. So here the problem is clustering algorithm. And then we have tried to split that problem into individual small parts of sub problems. Okay. So like cumulatively you'll be solving. So step by step you'll be solving this particular clustering algorithm. So there'll be various processes that will be going on, right? So in a particular problem. So like we'll be solving it one by one, and finally we will like cumulate all the solutions and then formulate the overall solution. Okay. So this clustering is nothing but grouping. So how we are going to group is that, okay, suppose that you have five elements. Okay, suppose that you have five elements. So among these five elements, you're going to choose which two elements are closest to each other. Okay. See, for example, here we have P, Q, R, S, T. So these are this representation of let's say points. Okay, so let's take this itself. Okay, so let's say P, Q, R, S, T points are there. Okay. So now what we do is we will find the points which are closest to each other, and then we will group them. So which is a first level of grouping. Okay. So if we group these two, what happens? These two together will become a single group or a single cluster, right? So cluster means you can just imagine, like, so in the galaxy and all, we see cluster of stars, right? Okay. So like a group of stars will form a galaxy, right? So and you can also see different patterns. They'll be forming the patterns and say this is one cluster of star, and other pattern Orion, like that, a star structure. So that is all clustering. So they'll form a different shape and then they'll group together, right? Okay, so that is actually called clustering. And here we cluster 2 points based on the distance. Okay, see, all these are scattered points. Among these scattered points, you found that S and T are closest to each other. So what you do is immediately you group them and then form a single cluster. Okay. So now these 2 points are not individual. Okay. Both of them combined together, it is a group actually. Okay. So we cannot represent 2 points which are in a group separately, right? So for that, what we're going to do is we'll just find the center point. See, suppose, okay. So here point one is there, point two is there. Okay. To represent this, suppose these two are the closest points, right? So what we do is we just group them together, and then to represent this particular group, what we do is we just take the center point. Okay. So this midpoint is going to represent this cluster, and all these are individual points as of now. Fine. So now this S and T, okay, is first grouped together, and then we can see that it is a single cluster. Now what you have to do is we have to eliminate these 2 points and then we have to replace these 2 points with this point. Okay. Now these 2 points are not there in the not there in concentration. Okay. So these 2 points have been replaced by a single point, which is the midpoint of these two points. We can also call it as a centroid. Okay. Centroid means what? It is actually the center point, but how we calculate centroid is it is the average of x's plus average of y's. Okay, that is actually a centroid. Okay, so now we have found out the center point. and then we have represented this st. Now what we do, having this as a point, and then other three points are also there. So do the same process. Find the nearest two points. Okay, distance between these two, and these two, and again all other combinations are there, right? Among these, find the smallest point, smallest distance. Okay, so it can be seen that P and Q are forming the smallest distance. So what you do, immediately group P and Q. Okay, so now we have how many points with respect to this level? P and Q are formed together, and then we have a single point, which is the midpoint of P and Q. Understood? Now we have one point to represent P and Q cluster, other point which is individual R, and then the third point which is the midpoint of S and T to represent ST group, S and T group. So 3 points are there. Okay. So now again what you do the same process, and now you find that R, this point, and ST point, okay, so this group are forming a cluster. Why? Because they are closest to each other. Now what you do is combine R with this group. Okay, now this group will become RST group. Okay, in this group we have, in this cluster we have R, S and T. 3 points are there. And what would be the point of representation for this RST group? Yes.
The midpoint of ST and midpoint will R basically.
Yeah. So the point which was representing ST, that point and R, the midpoint of these 2 points will be the overall like
RST
point of consideration for RST. Okay. So now we can also say that in like in general, it is the centroid of R, S and T, right? Put together R, S and T, that will be the centroid. Okay. So now you have only 2 points. So now these are the shortest 2 points. So you have the single overall cluster. So now here what we need to understand is how the grouping is being done. Okay, so this is actually called the dentogram, DENTOGRAM, dentogram. So like how the groups are being formed. Okay, this structure it will give until a single group is formed, you will be clustering. So you might ask, anyway, all the members are forming a single group only. So why don't we say straight away group all these into a single group, right? So, but the thing is, we are just identifying how the grouping is being done, and wherever we want, we can stop in the middle also. See, suppose I want two groups. I want this entire cluster to be formed as two groups. Okay, entire points to be clustered into two groups. Now, what I will do is I will stop when there are two groups. Okay, now P and Q will be a group, RST will be another group. Okay, so distance wise, nearer points will be grouped together. Now, if I want 3 points, what I would do? I would stop in the previous step itself. So PQ, R, and ST. So that would be the three different groups. So based on the requirement, I can stop at any level. Okay. So if we complete this just to find out how the grouping is being done, what would be the path taken? So this is a basic idea. Any doubts in this? Okay. So the question, hierarchical clustering. Can you please repeat the name of the pattern? Name of the pattern means?
I think
you said something pentogram or dentogram. I could not.
Dentogram. Yeah.
Okay, that.
And why only S and T? Why not P and Q, sir? See, actually, it is not that we should not take P and Q. So the process is that we are choosing the two nearest points. So if P and Q are the nearest points, and P and Q would be grouped first. Okay, so here it is found that S and T is nearer, so S and T is grouped together. That's all.
Sir, it's according to the diagram or
No. See, every point will have a. See, this is just a representation. Everything will have a coordinate, and for each coordinate, we are going to find the distance. Okay, these are all just see. Just imagine these points are there in this graph. Okay, so for every point you will find the equivalent distance. Okay, so you can find the distance between R and red and blue, green and orange. Okay, dark blue and light blue. So like that you'll find the distance, and then among all the distances, this distance is the smallest. Okay, the closest
yeah,
pair
got
is
it.
this one. So you will group them. Okay, so now the center point will be representation of these 2 points. Okay, after that you will find the next nearest points and then group them. Like that you will do this till you find a single graph, single cluster. Okay, and this is like a dentogram. Okay, so they're seeing what all 2 points will be grouped together. Okay, suppose if we take here, so which is the first one which is combined? Okay, so I think these values are different. Okay, fine. So now that is the basic idea. So you'll be given with a set of points, and then you're going to like keep on grouping the points based on the distance, and finally you will get a single group. So for to do that, we need to know some like so predefined calculations has to be done. For those only these many problems are there. Okay, first 7 problems are like prerequisites to do the 8th and 9th. So 8th and 9th problem are actual algorithms. Okay, so these would be like simple problems. We'll see one by one. So first problem is you're going to find the equivalent distance between 2 given points. Okay, so write a program to find the distance between 2 points. Here you are going to find out equivalent distance. What is equivalent distance? You have different distance parameters. Equivalent distance is the shortest distance between 2 points, and how it is calculated?
The square root of a square plus b square.
Yeah,
A is
this,
x2 minus x1.
correct. Okay, so square root of x2 minus x1 the whole square plus y2 minus y the whole square. So that is for 2D. So if there are multiple dimensions, then it keeps on adding. Okay, so next problem will be multiple dimensions. So that is what you're going to do in this problem. Simple, right? So you'll take 2 coordinates, and then you have to find the equivalent distance, and then you can just take care of all the constraints that are given. Okay, so they'll ask to print only 2 decimal points. All these things are there. Okay. So this is the first question. So second question is you have to generalize it for n dimensional points. The base question was 2 dimension, is for n dimension. So here this so here they given the dimension. So first input itself is the dimension. Okay. So if n is 4, you have to take 4 coordinates for the first uh, first point and 4 coordinates for the second point. Okay. So like that you can see if it is 10, then you have to take 10 coordinates. Okay, so it has to be generalized. I'm just showing the test cases, but still. So you understood, right? So it is a 4-dimensional point. So you have to take 4 coordinates for the first point and the 4 coordinates for second point. Now what is the formula? Equivalent. Here also you're going to find the equivalent distance between 2 points.
So it will be same under root of x2 sorry y1 no.
Yeah. So here the points are x1, x2, x3, x4 corresponds to point 1. y1, y2, y3, y4 corresponds to point 2. So 1 represents first coordinate, 2 represents second coordinate, 3 represents third coordinate, 4 represents fourth coordinate, right? So there'll be 4 coordinates, x, y coordinate like that, x, y, z like that, 4 coordinates are there. So now you have to find out the equivalent distance means square root of y1 minus x1 the whole square plus y2 minus x2 the whole square plus y3 minus x3 the whole square and y4 minus x4 the whole square. Understood? Okay, fine. So just give me a minute, I'll come back. Yeah. Okay. So here, so this is for n-dimensional space, the equivalent distance. Okay, so anyways, you're going to take square, right? Even if it is negative, it will become positive only. So if you put x1 minus x y1 or y1 minus x1, both are going to be same only. Plus So like this, it goes on, right? So how many dimensions are there? Those many times you have to put. So for this, what will you do? Again, you need to do an iteration and then find the sum of all the differences. So after finding the sum of all the differences, for the final value, you will do a square root. Understood? Okay. So this is for the second problem. Okay. The third problem is given a matrix of size n cross n. Okay. So write a program to find the minimum element in the matrix. So also like print the row index and column index of that minimum element. Okay. So you'll be given with a matrix. So in this entire matrix, you're going to find out the smallest element. Okay. So why we are doing this is, so here this matrix is going to represent the distance between 2 points. Okay. And the indices are going to be the points itself. Understood? See, you just imagine how we did for graph. The distance matrix for that, right? The same thing here. Okay. So like this was a graph. So if you take this as a graph, so to find out the distance between each and every point, okay, what did we do? We created a matrix, distance matrix, and then fill that entire matrix with the distances, right? So here we are going to calculate the distance and then fill that matrix. That's all. So in the graph problem, the distance will be given. Whereas here we're going to calculate the distance using the equivalent distance formula, and then we'll be filling the matrix. But here they have given the matrix itself. Okay, the matrix itself is given. Now using this matrix, you're going to find out the smallest element. So why are you finding the smallest element? That is what we are going to group, right? So the smallest element is nothing but the shortest distance. Okay. So once we find the shortest distance, and we should know which row, which column it is present. Okay. So now what happens is, which row, which column means which 2 points. The row represents the point 1, column represents the point 2. So now point 1 and point 2 are shortest to each other. That is what it represents. And we have the distance also. Are you clear with this? So in this problem, you're just going to find out the shortest, the smallest element among this entire matrix. So if there are multiple smallest elements, what you should do is you should take the first smallest element. Okay, if one is repeating here, okay, what you should do is you should take the first shortest point, first smallest element. Got this? So this is what it is going to lead to finally. Okay, so smaller problems will be leading to solve the largest big problem. Okay, so in this problem, so this is quite interesting problem. So given a matrix of size n cross n, write a program to find the average of all non-overlapping d cross d blocks in the matrix and display the values. If d cross d block cannot be formed, append additional zeros and find the average. Okay, so in this problem, there are how many rows are there? 5 rows and then 5 columns are there. Okay, and then how they are blocking? See, the blocks are done in 2 cross 2, right? So you can see all 2 cross 2 blocks are there, and except the last ones, because 2 cross 2 could not be formed because there is only one column here. So for that only, what they're telling is, if 2 cross 2 block cannot be formed, just like imagine that there is a 0 added. Okay, that depends on how many zeros you want. So, see, suppose it is 3 cross 3, and finally you are ending with one row. Then you have to add 2 rows of zeros, 2 columns of zeros. Okay, that depends on the problem. Okay, so in this problem, what you will be doing? Yeah, here you can see the problem. And here is the size of the matrix, which is 5. Okay, so they are assuming that it is a square matrix. Okay, 5 means just the number of rows is given Number of columns is also 5 because they're considering it as a square matrix. Now the block size is given as 2. So now what you're going to do is you're going to consider all 2 cross 2 blocks. So here I will not be able to form a 2 cross 2 block. So what I would do is add one column of 0. Understood? Like this. Likewise, here also 2 cross 2 block, another 2 cross 2 block, and then here 2 cross 2 could not be formed. So you'll be adding zeros and then forming the block. And here you can see only one column is there, right? So what happens here? 3 cross 3 you will take, sorry, 3 comma 4 you will take, and then you will add 2 zeros as the next row. Okay, so here also 0, 0. And for 7, you can see no rows, no columns also, only one element is there. So you'll be adding 3 zeros. Okay, the adjacently 3 zeros will be considered. Any doubts in this?
No, sir.
Okay, and finally you're printing all the block averages. So each and every block. So is the first block, second block, third block. Okay, fourth, fifth, sixth, seventh, eighth, ninth. So totally 9 values would be there. Okay, understood? See 1 plus 1, sorry, 1 plus 2 plus 3 plus 0, 6. Okay, 6 divided by 4 is 1.5. Okay, so this is your third problem. And this is the like so not okay, so this is actually reverse of the previous problem, but quite different. So write a program to convert a 1D array of size n to a matrix of size k cross k. Okay, so now what they're asking you to, they're asking you to convert a 1D array. So here is the 1D array 1, 2, 3, 4. Okay, so they want you to convert this 1D array of size k cross k into a matrix of size k cross k. So here there are 4 elements, right? Okay, and then k is 8. So you want to convert it to a 8 cross 8 matrix. So for that, what they are doing? So first they are splitting it into 2 cross 2 size, and then they are, see, if it is 2 cross 2, then I have to add 4 cross 4 elements for each element, right? So that is what they are doing. Okay, let us take. Okay, so I can see that the input will be like should be exactly matching. Then only you'll be able to form, right? See, like one more thing is this n value will definitely be a square value. Okay, will definitely be a square of a number. So then only you'll be able to form a square, right? See, what is 9? 9 is nothing but 3 square. See here 16 is nothing but 4 square. Here 4 is nothing but 2 square. Okay, so after finding that, it is easy to form a square. After forming a square, so based on the k value given, you can see how much to expand. Okay, so you'll get a 2 cross 2 matrix, and using that 2 cross 2 matrix, so it has to be converted to a 8 cross 8 matrix. So 2 cross 2 should be converted to 8 cross 8 matrix. So it should be scaled by a factor of 4. Okay, so each element will become a 4 cross 4 matrix. And here you can see, so now this 9 will be converted to a 3 cross 3 matrix, and this 3 cross 3 matrix should be converted to a 9 cross 9 matrix. So it is scaled by a factor of 3, right? So every individual element should be converted to a 3 cross 3 block. Understood? Any doubts in this problem? Likewise here also, 16 is there, you'll get a 4 cross 4 block. 4 cross 4 block should be converted to a 4 cross 4 block only. So the same numbers will be taken over here. Any doubts in this problem? Understood? So now the thing is, you need to understand the problem statement. Okay, so logic you can like you can just work it out in a paper and then see how it can be done. Is it fine? Yeah. Okay, I'll repeat this problem. See here, they have given the question is you have to convert a one-dimensional array to a matrix of size k cross k. Okay, so when can we do this is n value should be a square. Then only we can form a smaller matrix, right? See, so n is 4. So what is the square root of 4? It is 2, right? So using 4 elements, we can form a 2 cross 2 matrix. Likewise, here if you see, n is 9. Square root of 9 is what? 3. So using 9 elements, you can form a 3 cross 3 matrix. Okay. So now here also 16. 16 elements are there. Square root of 16 is 4. So you can form a 4 cross 4 matrix. Now if you take the first sample, this 2 cross 2 matrix which we formed needs to be converted to a 8 cross 8 matrix. So 2 cross 2 is converted to a 8 cross 8 matrix. Understood? So if you want to do that, so it should be scaled by a factor of 4. So every individual element will be converted to a 4 cross 4 matrix. See, 1 converted to a 4 cross 4 matrix, 2 converted to a 4 cross 4 matrix, likewise 3 and then 4. So here 3 cross 3 got converted to a 9 cross 9 matrix, right? So every element by a factor of 3. So every individual element should be converted to a 3 cross 3 matrix. Okay.
Okay, sir.
Yeah. So now we are getting into the problem. So we're going to formulate a distance matrix. Okay. So given the features of n objects. So here features are nothing but x and y coordinates. Okay. So they are just bringing in machine learning terms and all. So it is feature is nothing but the x and y coordinate. Okay. So now they are just assuming that, okay, so it is just a two-dimensional point. Okay. So if it is n-dimensional point, then you have to actually here they have directly given they are two-dimensional points only. So no need to worry about n-dimensional. So just assume that all the points are two-dimensional. And there are n objects. Okay. So in this case, there are 3 objects. Okay. So if there are 3 objects, then what would be the size of the distance matrix? Three cross three, right? Okay. See, like these 3 objects are nothing but 3 vertices of a graph. So if we have 3 vertices in a graph, you'll be forming a distance matrix of size number of vertex plus number of vertex, right? The same thing here also. Okay. So you should form a distance matrix of size 3 cross 3, and then you have to fill the values here. See, these values are nothing but distance between each pair. See, 3 points are there, 0.1, 0.2, and 0.3. So, one minute, let me take the Excel sheet. So 3 points are there, and you're going to construct a 3 cross 3 matrix. Okay. So this is suppose 0.0, 0.1, 0.2. This is 0.0, 0.1, 0.2. And each of the points are having coordinates. Right? So these are the coordinates of 0.0, 0.1, and then 0.2. So now what would be the distance between 0th point and 0th point?
0.
0, because both are same points. If you apply equivalent distance formula, you'll get 0 only. So 0. So 0th point and first point. So apply equivalent distance formula and then find the distance between 0th point and the first point. Okay. So between 1, 1 and 2, 2. So the distance would be 1.14. Okay, square root of 1 minus 1 plus, sorry, 1 minus 2 plus 1 minus 2. So square root of 2 would be 1.14, and that is what is the answer. So what is this one? This value?
So 0 and 2.
Yeah, so distance between the point 0 and point 2. So likewise, this point is nothing but distance between point 1 and
1.
sorry, point 1 and 0, and this is 1 and 1, and then this is 1 and 2. Okay, and then here also. That's it. So this is your next distance, sixth question, which is distance matrix. So there might be any number of points given. Okay, these are few test cases. Okay, there can be any number of points, and those many number of the size of the matrix also will be those many number. Okay, n cross n matrix you have to create. Okay. Now, so you have found out the distance matrix, right? After finding the distance matrix, you're going to find the nearest neighbors. Okay. So here let us read the problem. Given the features of n objects, which is nothing but the coordinates of n objects, and a specific object A. Okay. So they are mentioning to which point you want to find the neighbors. Okay. Find k nearest neighbors to object A. So the problem I'll repeat. So you'll be given with the coordinates of n points, and then the point for which you're going to find the neighbors, and how many neighbors you're going to find out? K number of neighbors. So all these things will be given in the problem. So first, there are 5 points. Okay, number of points is 5, and the number of features to represent an object. Okay, so this is number of features represent an object is 2. See here they are generalizing. Okay, if 3 is given, then you have to be careful. Okay, so you have to find the equal distance between 2 points with 3 coordinates. Okay, if this point is 4, then 4 coordinates. Like that, it changes. Okay, you have to write a generalized code. Fine. So after finding the distances, and you'll be creating a distance matrix, right? And then they're telling that, so they want you to find number of features object. The value is 3, the k value is 3. So you have to find the 3 nearest neighbors, 3 closest points. Okay, so how to find the 3 closest points is that you want to find from the distance matrix. Okay, from the distance matrix, you're going to find the smallest 3 points. Okay, so in the previous problem we found the distance matrix, right? So from this distance matrix, leave this diagonal. Okay, see, actually distance matrix would be symmetric, right? One more thing you have to mainly note, the distance matrix is going to be symmetric. So just consider the upper part of the triangle or the lower part of the triangle. So if it is a 5 cross 5 matrix, 5 points are there, so you'll be getting a 5 cross 5 matrix, right? Okay, so this point is actually the distance between the 0th point and the 3rd point. And symmetrically, you can see this point. So this point is nothing but the distance between the 3rd point and the 0th point. So if you're calculating distance between 0 and 3 or 3 to 0, both are going to be the same, right? Okay. So that is why this matrix is going to be a symmetric matrix. Okay, see here, this would be distance between 4 and 1. Okay, and this point would be the distance between 1 and 4. And these 2 points would be the same. Okay, because distance between 1 and 4 or 4 and 1 both are same, right? That's why. So now what you do is, don't consider the entire matrix. Just consider the upper part of the matrix. You can choose, okay? Either you can choose the upper part of the matrix or the lower part of the matrix, excluding the diagonal. So don't include the diagonal because all the diagonal values are zeros, right? So if you calculate, then what happens is it will take all zeros as the smallest distance. Now your task is to find the first three smallest values within within these elements. So that is based on the k value, right? If k value is 3, you're going to find the smallest three elements. If k value is 4, then 4 elements. Understood this problem? Any doubts? I'll repeat again. You'll be given with n elements. Okay, so n objects will be given, and then the features of those n objects are also given. Okay, so number of features. Yeah. Okay, so I'll just repeat the problem. So you will be given with n objects, and these n objects will have a specified number of dimensions. Okay, the dimension is specified here. So if 2 means 2 dimension, 3 means 3 dimension, like that. So now what you're going to do is you're going to find the k nearest neighbors. Okay, so k nearest neighbors means what? First, you're going to find out the distance matrix. So after finding the distance matrix, so what you would do is you'll be filling this distance matrix, right? So that it is 5 cross 5, 5 elements are there. So it will be a 5 cross 5 matrix. And you just consider the top half, so upper triangle of this matrix. From this upper triangle, just find out uh, the smallest k number of values. If k is 3, find the first smallest 3 values. Okay, like that you just find out, and then the corresponding, suppose if this point is the smallest. Okay, so now what would you do? You will take 0.1 and 0.3. Okay, so after that you find this particular point is smallest. You will get 0 and 2, right? So actually, okay. Sorry. Okay, so just forget about that. I'll just repeat the problem. See, the problem is given the features of n objects, okay, and a specified object A, a specific object A, find the k nearest neighbors of that object A. Okay, so here, so number of objects is 5, and they're given the number of features also. So now at the last, you can see they are mentioning the feature vector A also. So to this A, you're going to find out what are the nearest values, nearest neighbors. Okay, so you can just imagine this in a graph: 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. 6, 6 is the object, right? See, if you consider this, okay, as you just imagine this as a graph, and then the coordinates are like this, okay? So this is 0.1. Okay, and 2 comma 2 is 0.2. 3 comma 3 is 0.3. This is 0.5. Okay, so these are the given points, and they are asking you to find. See, understood? These are the 5 points given, and they are asking you to find out for this point A which are the closest elements. Okay, so this is the new point, point A. So for this point, the closest points are these 3 points only, right? So this is 0.5, this is 0.4, 3, 2, and 1. So for A, the closest points are 5, 4, and 3. So that is what they are given here. Understood? So you're going to find the for A, which is the shortest distance, and that point would be the point 1. And again, you find the shortest distance among the rest of the points. Leave this point, and then among the rest of the points, find the shortest point. Okay, that one you can do, or you can also. So this is optimized, but actually, the straightforward method is that you're going to sort it in ascending order. First, find the distance between each point, and then sort it in ascending order. Then take the first k elements. That also you can do. Okay, but complexity wise, the optimal solution is first finding the smallest, shortest distance. Okay, and then eliminating it from the list. Take the second shortest from this list. Find the shortest. Okay, that will be the shortest distance. Eliminate it. Then again do the same process. Understood? Okay.
So for 5, didn't you consider 5?
Sorry.
You said that the shortest distance you'll consider from leave the 5th point and start from.
No. Yeah. See, first itself, we are first for the entire 5 elements. You're going to find the shortest distance, and you find that 5 is the shortest distance.
Okay.
So after that, you leave 5 among these 4 elements. Find the shortest distance between A. Okay. So like this, you can find the first 3 shortest distances. Okay. So this is your 7th problem. Now, so this is the first iteration of hierarchical clustering. So first iteration means what? So you're going to do the first step alone. That is grouping of the first 2 shortest points. Okay. So hierarchical clustering starts by treating each observation as separate clusters. So if there are 6 points are there, right? So all these 6 points are individually considered as clusters. So cluster 1, cluster 2, cluster 3, like that. All these are considered as individual clusters. Okay, then it repeatedly executes the following 2 steps. So the first step is identify the 2 clusters which are closest together and merge the 2 most similar clusters, that is the closest clusters. Okay, this continue until all the clusters are merged together. So first A and B were the shortest, so they were combined together. Then E and F were combined together. Okay, and then this cluster and D was shortest, so these 2 were combined together. And this was combined to C. And finally, this entire cluster is combined to D. Okay. Now this is actually the entire process, but in this first, we're going to do the first step alone. We're going to do first. So given the features of n objects, write a program to simulate the first step of hierarchical clustering algorithm. Okay. So the inputs are going to be all inputs are integers. Display a float value corresponding correct to 2 decimal places. Okay, that is all fine. Okay. So now here they have given 4 objects. Okay. And then for each object, there are 2 features. And this is generalized. Okay. So if there are 3 features, then again you have to consider 3 dimension like that. Okay. So now here, yeah. So 4 objects are there, 4 features, sorry, 2 features. Each object has 2 features. And then using these using these four objects, you are considering a 4 cross 4 matrix. Okay, so this is actually a distance matrix. You're considering a 4 cross 4 distance matrix. So after considering the 4 cross 4 distance matrix, you find out which is the smallest element in this matrix. Okay, so just consider the top upper triangle. Okay, don't consider the entire matrix, just consider the upper triangle. From the upper triangle, you're going to pick the smallest element, smallest value. So this would be the shortest distance, right? This entire representation is a distance representation of these points. Okay, so now among these, the smallest one will be the shortest, closest pair. And how to find those two elements is nothing but the row value and the column value. Okay, now what they're doing is they are considering the last value. Okay, is taken, right? So in this, you have 1 and 4. Okay, so what happens is the smallest element is there, right? 1, that will be considered as the index of that particular value. See, this one you're taking, and then you have to replace that with a point, right? Okay, so 1 and 4 are combined together into a single cluster. So what is 1? 1 comma 0, and 4 is 2 comma 1. Okay, and then the centroid value of 1 and 2 will be considered as the overall point for these two, and then using that again from the distance matrix. Okay, so here the first point is nothing but mm, mm, so this is 7.21. Mm, this should be a different value. Oh, okay, see, actually what happens here is the first point has to be converted to the centroid point of 1 and 4, and having that as a point, again you're going to formulate a distance matrix, and this distance matrix is nothing but the first point which we represented as the midpoint of 1 and 4 with the distance of 2. Okay, second point, and that with the distance of 3. Okay, like that you'll get a different distance matrix here. Okay, I'll just check this sample and update it if needed, but the concept is the first point becomes the midpoint of the first point and the fourth point. Okay, so are you able to get it? See, this is the shortest value, so smallest value. So smallest value means these the coordinate of this particular point, which is nothing but 0 comma 3, right? So which is the first point and the fourth point. So first point and fourth point are forming the shortest distance, which means you are clustering together. So what happens is the first point should be represented by the midpoint of first point and fourth point. So it will be a different coordinate value, right? Minus 0. Oh, I think it's 1 comma. Yeah. So it will be a different mid value. So mid value will be there. So that mid value should be considered as the point 1. And then you are going to find the distance between the other 2 points. Did you get the idea for this?
Yes, sir. But it will keep changing every
Yeah,
time.
it will keep changing. Correct.
And till how long we have to do this?
This is for the first iteration.
Okay.
So this problem you have to do only for the first iteration.
Okay, first iteration only. Okay.
Yeah. So this particular piece of code, whatever you write here, should be put in a loop, and then we have to do the last problem. Till which point is that? Till you get a single point. Okay, so they're just formulating the cluster itself. So what cluster will be formed? So they're using giving a name. Okay, so first there are 5 people. Actually, 6 people are there. So what is the distance between these two? All the people is found out, and the distance matrix is found. And then among those, the first level they found that Amar and Dana are closest to each other, and then they are forming a single group, cluster 3. Okay, now their center point will be taken as cluster 3, and then again formulate the distance. Okay, so if you do that, you can see that next Arun and Giri would be forming a single cluster. Okay, so that would be cluster 1, and cluster 3 would be Amar and Dana itself, and then we have the other individual points. Okay, so now in the third iteration, what happens? This is the second iteration. The first iteration, Amar and Dana got grouped. In second iteration, Arun and Giri got grouped. Okay. In the third iteration, Sasi and Peri will get grouped. Third cluster. And then again do the same process. Arun, Giri, Amar, Dana. So which one? Cluster 1 and cluster 3 will form a single group. Okay. And then finally only 2 elements are there. So they have to be the shortest. So all of them will get grouped in a single group. So you have to proceed this previous algorithm for till you reach a single element cluster. That is a single cluster. Understood? See, if you start solving the first few problems, you will come to know. And then if you solve the 7th problem, the 8th problem would be easy. Just an additional work you need to do. So you understood the overall concept, right? All of you?
Yes, sir.
Okay, just try to solve all these problems. Okay, we can discuss the solution one by one in the next 2 classes. Okay, and this is second project. And the first project would be on genetic algorithm. Okay, so that will also be interesting problem. So we'll see how mutation happens, and then we'll be nearing to a solution. We'll be taking it taking a problem and then we'll be solving that. Okay, and then the third project would be the real project that was done in our company, which is called Backtrack Project. So it is actually a background verification project. Okay, so like how automation can be done in background verification, we just created a small part of that. Okay, the text processing part of that project, and then we have built like small modules, different set of problems. So that would also be interesting. That is more of regular expression and string processing. And the first project would be all logic based only. Okay, fine. So I can just go through the problems and give a try to all these problems. We can discuss the next class. Okay. Any other doubts in this project?
Okay. Till now, no doubts.
Okay. You just try it once and then you'll come with, you can ask doubts in the next class.
Okay.
Okay. So thank you all. Can meet in next class.